In today's lesson, we're going to be looking at finding an angle using trigonometry. Alright, we're going to look at an aside before we begin. We're going to solve equations with trig functions inside them. So sometimes our pronumerals in this situation are going to find their way into the angle position rather than the side position, and when they do this we need to be able to have a way to solve this equation. So if we look at a simple equation, sine theta equals 0.5. Now, as before, we need to isolate the pronumeral in order to figure out its value. So in order to do that, we need to find an opposite operation, and we need to perform that opposite operation to both sides. Now, the opposite operation for sine is inverse sine, or sine to the -1. So if we take inverse sine of both sides of this equation, we have something that looks like this. Inverse sine of sine theta equals inverse sine of 0.5. Now, the inverse sine and sine are going to cancel each other out, leaving us with an isolated theta. Theta equals inverse sine of 0.5. Now we type that in the calculator and we get our answer of 30. So here, theta equals 30 degrees. Take a moment to copy that down. Alright, a second aside today, we're going to look at rounding an angle. And we need to be able to do this because sometimes our answers when we use the calculator will not come up as a nice neat number like 30. And they will first come up as a decimal. In order to change our answers into angles, which is what they actually are, we need to push the angle button. Now, angles are made up of degrees, minutes, and seconds. And this is what your calculator will display after you push the angle button. Now, sometimes we're going to want to round that to make it a smaller answer, an approximation. So we'll be asked to round to the nearest degree or the nearest minute. Now, minutes and seconds are both out of 60, just like they are in time. And if we're going to round up or down, we're going to base that on halfway, which is 30. Now, the angle above there, 70 degrees, 47 minutes, 13.28 seconds, is going to be rounded to 71 to the nearest degree, because 47 minutes is more than 30 minutes. So this angle is actually closer to 71 degrees than it is to 70 degrees. And likewise, we're going to round it to 70 degrees and 47 minutes because it's closer to 70 degrees 47 minutes than it is to 70 degrees 48 minutes because the seconds is less than 30. Take a moment to copy that down. The steps for finding an angle. These steps are exactly the same as they have been in the previous lessons. This time though we're going to be finding an angle rather than a side. So start by scribbling, labelling the sides, hypotenuse, opposite and adjacent. Examine the sides. Here we can see opposite and hypotenuse. Choose sine, cos or tan from SOHCAHTOA. Opposite and hypotenuse is sine. Substitute all our known values. This time theta is going to remain as theta. Opposite will be 8, hypotenuse will be 17. Now we're going to solve this equation by using inverse trig. We're going to use inverse sine to find theta in this case. So theta equals inverse sine of 8 over 17, which we type in the calculator. This is going to display 28.07248694. Then we're going to push the angle button to get 28 degrees, 4 minutes, 20.95 seconds. Now we're going to round this to the nearest minute. We can see that the seconds is less than 30, so we're going to stay at 4 minutes. So our answer to this question will be 28 degrees and 4 minutes to the nearest minute. Alright, 2 examples. First example, following our steps, same as before, figure out which ratio we need to use, and opposite and adjacent should be tan. Filling in the information, tan theta equals 9 over 7. This time we're going to take inverse tan of both sides. So we get theta equals inverse tan of 9 over 7, which gives us 52.1250165, or 52 degrees, 7 minutes, 30.06 seconds. Now to the nearest minute, because we have more than 30 seconds, this will be rounded up to 8 minutes. So 52 degrees, 8 minutes. Example 2. Same thing. Figure out which ratio we're using by examining our sides. In this case, it's adjacent and hypotenuse, which is cos. And filling in our missing information, we have cos theta equals 1.9 over 4.1. Inverse cos this time, so theta equals inverse cos of 1.9 over 4.1, giving us 62.39233,194, or 62 degrees, 23 minutes, 32.39 seconds. Now, this time we're going to round to the nearest degree, which is just 62 degrees because the minutes is less than 30. So we stay at 62 degrees. Take a moment to copy that down. Alright, in today's lesson we've looked at finding the sides of an angle in a right angle triangle. So now we have all of our skills finding sides, finding angles, to be able to answer any question associated with a right angle triangle and some sort of missing information.